Assalamualaikum and hi to all. Okay, because we can't to finish all the module, so I made this video just to cover for module 9, and as promised we're going to have like extra classes or any Q&A later on. We're going to have extra classes and it is not compulsory. For those who thinks that it is good for you to join, then you can come to join the extra class later on. Okay, for module 9, some of section already cover part of section module 9, but some is not yet covered. So throughout over here, we have all the module 9 under shift register. So there is a several objective that you need to comply throughout the module 9. So the objective are to introduce the characteristic and functions of shift register, to highlight different types of shift register, to introduce shift register IC, and lastly to explain shift register counter. So in this module, it's going to contain on several parts, which is first basic shift register, and another one is bi-direction shift register. You need to know, similar to like your gates last time, you learned that gates there are a few basic gates which are in gates, not gates, and also OR gates, right? Similar to this shift register, there are basic gates before you can have much more complex in the register developments. So throughout you can have serial in, serial out, which is we call as SISO. Serial in, parallel out, we call as SIPO. Parallel in, serial out, we call as PISO. And lastly, parallel in, parallel out, we call as PIPO. Okay, all of these basic shift register, you need to know in terms of the names. Sometimes, as I mentioned, the very easier things you always left it, and you say okay, because this is easy, you don't want to focus more. That's why sometimes you just lost 1 mark, 2 marks, which is very easy things that you can score, but because a very simple mistake, like might be it is serial, but there is an objective question in multiple choice that might be call it as what shift in, shift out might be, so it's called as SISO, and you just remember the SISO, so you say okay, it is shift in, shift out, oh it's correct, but throughout this is the correct name, right? So that's why I want you to remember the long name and also the short name. Okay, instead of having just basic shift register, you can have also bi-directions shift register, whereby there are two, which is ring counter and Johnson counter. Some of you already done with the basic shift register last time, but it's okay, we just do a recap, but some of you still not yet cover, so here I need to explain back. Okay, this is a basic shift register and this is bi-direction shift register. Okay, what is shift register? Shift register is a register which binary data can be stored. So you can think, okay, if it is shift register or XR, you can store a binary data. Okay, yeah, where you can apply. So you can remember whenever you have the binary data to be stored, you can use the shift register. And this data can be shifted, you can see. So there is two key. You can store the bit or binary data, and it can also shift your binary data in your shift register to the left or even to the right. It's depending on your setting or whatever scenario that you apply to. When a signal is applied, and it consists of arrangements of flip-flops. So you have several flip-flop. When you combine together, you can get through your shift register. So where you can refer, which is on the module page 33. Digital system important in application which is involving in data storage and also data transfer or movement, which is both is covered. You can see the data storage. You can store using your shift register, and also your data transfer and movement is also having here. So that's why it can be used in a digital system. And this function you can find out on the module page number 7. Okay, the flip-flop as a storage element. So you can see here the example here shows that this is D flip-flop, and when you have the input of 1 to your D inputs, you're going to have the Q. You can see here the Q will be also similar to the D, if you still remember the table of your D flip-flop. So when 1 is on the D, Q become 1. At the trigger age, might be for this one is a positive clock. So when you have the trigger positive clock, it's going to be remain as 1. And if you have 0, you're going to have also Q as a 0. It is become as a 0 when you have a trigger, whether it's a positive clock or maybe it is a negative clock, depending on your clock here, right? Or remain as 0 if already triggered. So it's going to remain until you have another trigger clock, isn't it? And it's always follow your D. So each flip-flop can store only one bit data. So please remember this. That's why last time if you have like a counter for 1 bit, you're going to have one flip-flop only. Counter that have a 2 bit, you're going to apply and having the 2 flip-flop. When you have 3 bits, you're going to have 3 flip-flop, and etc. So more bits require more flip-flop. So last time you already know that one flip-flop can store only 1 bit data. And in terms of the movement here, okay, serials, whether it is in or out, serial normally from left to right, right to left. Okay, it's depending on the arrow also. If it is pointing in, then it's called in. But if it is from left or even a right, is called as serial. So you can see here example number A here, it is serial and it's pointing in. Okay, there is another one, it is pointing in and is from left, so it's called as serial. Where okay, this one also from the left here, you have the serial in because it's pointing in. Okay, only that. Then you have another one which is we call it as serial also. You can see if it's go in or go out, it's still called as serial. If it's pointing out, it's called out, serial out. So that's why for this one we call as serial in, shift right, serial out. Because why is shift right? It's going to move to your right there. And for this part, you can see you are pointing to the in here, which is serial in, where it's going to move left, shift left, and serial out. For this one, okay, before that, go for your parallel. Parallel, it depends on whether it is from up and down. So you know, like horizontal or vertical. So here, if parallel, is going to be pointing from up. So you have parallel in. You can see here. Okay, this is parallel in, and where it goes, if it go to the left or to the right, it is going to be a serial, as mentioned before this. So it's going to go to serial up. It's not going to mention where it goes because you know it is from up. Then if it is serial up, it's going to go to up there. And there is another, you can see, if you have serial in there and go down there, it's called as parallel. And if it is from go out, it's called as out. And you can see also you have a parallel in, parallel out. From up to down, parallel in, parallel out. And these two scenario, you can see there is no whether it's going to shift to the right or to the left, because you know it's going to be not including the shifting part. And for this one, it is rotate to the right, it is continuous, and this is rotate to the left. Okay, so that is on the basic data transfer movement in your shift register. So for shift register there, and we have SISO, PISO, SIPO, and lastly our PIPO. That is all the basic shift register that we can have. Okay, now this is example from the view of data transfer you can have here. A register can shift data one bit at one time. When you have done for another one bit, you go for another one bit, you go for another one bit. You cannot just directly jump to the end. The logical configuration of serial of your SR. Okay, I call it SR. You need to know SR is shift register. A change of flip-flop connected to in cascade. This is cascade connecting. The operation of SR we in a synchronize. Remember back about synchronize. Synchronize mean when you have a similar clock connected to all the flip-flop. So only one sources of clock. You can see this is similar clock, this is similar clock, and similar clock. Using a common clock. And shifting n bit SR, we lost all data after 2n clock cycle. So because of this is going to be a problem, because after 2n clock cycle you have lost all the data. So how to overcome the problem? You're going to using the rotate. So you can see you have a rotate right or rotate left. Okay, let's take a look into one by one on the SISO first, which is serial in, serial out. So what is the function of SISO? SISO accept data serially. One bit which is input at one time on a single line. Each clock pulse will enter one bit data, which is your data in, into your SR, and at the same time one bit will be shifted to your maximum, which is your output. If let's say your output you're going to have, I guess over here 8 bits. 8 bits here. I can't see here. Okay, it's 8 bit. Output produced in serial form too. So you can also have a serial form too. Here you have your data in, you have your clock. And it is depending on where you're going to connect. It's depend on your flip-flop that you are using. But this is a block diagram, the general one. So logic symbol for 8-bit serial in, serial out shift register. Okay, this is shows you the example. If you have 4 bits, 1010 begin enters serially into the register. So every clock cycle, data is shifted to the right position of your flip-flop. Of course, for n-bit SISO, it's require n clock cycle to completely entering the shift register. For the first data enter to appear at the output. So LSB shift in first. If you have 1010, where are you going to shift first? This one. This is your LSB. Okay. So let's take a look. This is the example when you have you're going to put in your LSB first. So there is a 0 input here, 0. In the beginning, of course, it's all going to be 0, right? After for first clock, you're going to have 0. Of course, your D here, your Q0 will be 0 because your D will be following your input. And then the rest will be also 0 because you can see it's connected to each other. You get the output of 0. Second clock, you have what? Okay, this is first clock. This is your second clock. Another bits will be entered in. So you're going to shift from this one is 0, right? In the initial part, this is 0, 0, 0. And then after that, when you have the feed in of 1, this flip-flop will be 1, and this input will be shifted to here. So you can see here, it already shifted to this. Then this is a new output for your D0, flip-flop 0. Sorry, not D0, flip-flop 0. Okay, so you have 0, 1. And when you have another, the third one, you're going to move this to here and this one to here, and the new input will be at this first flip-flop. Okay, then you get here. And lastly, this bit 4, the MSB, you're going to have 1. So everything will be shift. You can see this will be shift 0, this will be shift 1, this will be 0, and then this is 1. After clock 4, the 4-bit number is completely stored in your register. So that is in terms of the example. If you have a 4-bit 1010, okay. Now 4-bit begins serially shift out of the register and replaced by 0 after you already in, right? This is the process of store in. Now there is another scenario, which is you're going to shift out. You have apa? Shift in, shift out. So you're going to shift it out. So first output, this will be go to the output. And then next, clock number 5 is going to be like this because this already shifted to the right. You can see, and this will be here, this will be here, because this and already goes to the output, which is shift out. Okay, now you can see here first it will be 0. Clock number 6, this one will be go out and the rest will be shifted. So that's why it will be here. After that, clock number 7, you're going to shift this to be the output there, and this one will be shifted. This will be shifted to here. That's why you can see it's here at your clock 7. And lastly, clock 8, which is 2n. If you still remember, 2n. N is your 4-bit. 4 times 2 is going to be 8. So everything is finished and already done at your cycle to end cycle. So cycle number 8 is going to be 0, 0, 0, and the output, the last output will be stored here. And it's already done your shift out. This at this page it is shift in, and this is shift out. So you can see here. Okay, so that is for n bit of SISO, it requires n clock cycle to shift in all the data. Means that you can see here, you have clock 1, 2, 3, 4 to complete shift in, and then another 4 clock, 5, 6, 7, 8 to finish your shift out. N clock for shift in and another n clock for shift out all the data. So what is the n bits, which is at the beginning you're going to have 4 bits. That's why 4 bit for shift in and another 4 bit for shift out. That is on your SISO. It is not too hard. You just need to know. Okay, you just need to know the step following. Okay, there is another example of SISO. For this one is 4 bits also. Okay, sorry. Okay, now you have the block diagram there. You can have the data in clock Q3 is the maximum because you're going to have Q0, Q1, Q2, Q3 for the 4 bits, isn't it? So you have this data you're going to shift in, and then you're going to have another shift out. 4 cycle for shift in, another 4 cycle for shift out. So what the data that will be shift in? So this is the flow in terms of table. Just now in terms of the picture, you can see basically what is the flow in terms of a flip-flop. But as I mentioned, you're going to have your embedded close equations, and normally we can't to like give you the way for you to draw and etc. So normally we're going to give you a table. So I want you to understand also how you're going to show it in terms of table, or might be in terms of the picture here, in terms of the sequence 1, 2, 3, and 4. So it is similar to this table. Okay, let's we look into the table. I hope that you can know 2 ways in terms of the pictures just now, which is for your understanding, and another one is for you to understand the table. Okay, for the first time, you can see here, you're going to have similar things. Allah, wait you have 4 flip-flop for 4 bits, and okay, we're going to connect like this. So just example, okay, this one if your for your Q3. So initially, as mentioned just now, you're going to have 0, 0, 0, 0 for initial value. And for the first time, what is the data that will be filled in? It's going to be start from your LSB, as I mentioned. So this will be fit into this first flip-flop. So what is the output for this one? It's going to be 1. And what is the rest? It will be remain 0, 0, 0. Okay, so that's why for this clock 1, this is clock 1, right? For your clock 1, it's going to be flip-flop 0 will be 1 there. The rest will be 0, 0, 0. Okay, second, what is the data? Now it is 0 there. Why it is 1? SISO, serials in, serials out. Okay, for this case, it is slightly different, because for this one you're going to LSB will be shift first. If you have this one is serial in, serial out. Yeah, supposedly it's similar. Wait, I double check. Serial in, serial out. SISO. Is it SISO? So okay, let's assume that the question asks you to do the input of your MSB fill in first. The last FF will hold your MSB. So it's going to be serials. It's going to be come out with the MSB first. So for the rest, you're going to see it's going to be MSB will go out first. So it is similar. You can see here, the first thing you're going to take this one, and then after that is follow for this. That's why the number 2 clock here. And then the third one is this, is this 0 there. And lastly, your 1 here. So that's why you're going to have 1, 0, 1, 1. Compared to just now, you're going to have, it mentions that you need to LFB shift in first. Enter your serial into the register. So you're going to enter this LSB first. So when your question asks you to have the MSB will insert first, then you're going to go for your MSB, the data in and the data out. Okay, this is shift in, and you're going to have the shift out, similar process just now like this. Another 4 clocks is going to be shift out. So that's why you're going to shift out this first, and then followed by this, and then followed by this, and lastly this one. So let's take a look in terms of the table. So first you're going to come out with, this is the initial from this part. And then another clock, which is supposedly clock 5, 6, 7, 8. It's going to come out one by one. So for this, it's going to come out this, isn't it? So this will be goes here, your data loss out. And then the rest will be shifted. So another one, this will be out. And it's remain this one. These two will be remain. And then it shift to the right. And another one, clock number 7, it will shift again. The 0 will be come out, and 1 will be here. And lastly, 1 will be out, and the rest will be 0, 0, 0. Okay, so that is on the example LSB, MSB. Now you have another example, but this one is what we call 5 bits. So you're going to go to write SR. I think this one should inform whether it is goes to the left or to the right. The question is not complete. That's why it is not too clear. Okay, it's okay, but this one is mentioned you that is going to shift to the right. So the data input is this one. Initially, of course, your flip-flop are clear and MSB are shifted in first because you're going to move to the right, I guess. If you having the shift left, it's going to shows you whether it is shift left or shift right. So shift left is going to move this first, your LSP, and then if you move to the right, what is the consequence? But you will be given with a complete question. Just now it is not complete whether you're going to fit in the LSP or MSB, but example number 3 is clear. You can see MSB are shifted in, so you're going to shift this first, and please make sure you have 5 bit. That's why you have serial in 5 clock and serial out another 5 clock until your clock number 10. So let's take a look in terms of, okay, this is the example. You have 5 flip-flop there. And see another example in terms of your timing diagram. But I guess in your final exam, we're going to go for table. Okay, so I want you to get familiar with this because you need to fill in the value for your, you can see here timing diagram is hardly for you to draw in your e-learning, but it's okay. You can see this is your first clock, second, third, and fourth, and lastly fifth. Okay, your data in, you're going to have 1010 11010 11010. So you're going to have first clock for your first flip-flop, which is Q. Your input now is 1, so that's why it's going to be 1 there. After that, you have this is clock 1. You have a first 1 there, and then for clock 2, what is your output? So here is 1, and then it's going to move to here. The 1 will be moved to this for your Q1. You can see that's why your Q1 is 1. But now you have 1 also for your Q1 here. That's why you have 1 also. So might be for you, if you're familiar with this step by step just now, you can try to understand this first. Then you can go to your table here. After you can know, then you can imagine that for your first clock here, this is your first clock for your flip-flop 1, first clock. So you're going to have 1 for Q0, and the rest will be 0, 0, 0. If you have clock 2, after your clock 2, the 1 for your MSB, because it's mentioned shift in, right? So this MSB will be here. For now, your Q1 is 1. The rest still remains 0. And what is your value for your next Q0? Is your 1. That's why you can see here for the first one, it will be 1, 0, 0, 0, 0. Second clock is going to be 1 for this, and another 1 just now for this part will be moved here. It will be 1 there. The rest will be 0, 0, 0. Okay, next, this one will be shifted to this after your clock 3, at your clock 3, right? This one will be here. So now your Q2 will be 0. Q3 is Q2 will be 1. Q3 will be 0, and then this is 0. So that's why you can see at your clock 3 here, this is 1. The rest is remain 0. And 1 from your Q0 will be shifted to your Q1. So that's why Q1 will be 1 also. And what is the value now for your third one? It is a 0 there for your Q0. Okay, after that you have clock 4. What is happening? This one will be moved to here, this one will be moved to here, D0 will be moved here, and your input now it is 1. So you have 1 0 1 1 0, and following the fifth one, D0 will be goes here, sorry, this one, right? 1 will be go here, and this one will be go here, D0 will be go here, this one will be go here, and the last input will be 0. So you have 0 1 0 1 1. This is your 5 clock, and it is just for your shift in. After that, you're going to do your shift out. Okay, this is in terms of table. Okay, and then you're going to have your shift out. What will happen for your shift out? It is not showing here. This one is what? Testing, generate a table from the shift out. Okay, they ask you to generate the table for shift out. It is good for your exercise there. For your shift out, you're going to have clock number 6, 7, 8, 9, 10. So first is going to go out this first, isn't it? So this will be up, second will be up, third, and extra. You're going to come out with this diagram and also the table. Try to do it because you need to answer in terms of your final exam later on in the table. Okay, so that is on your SISO. Later on in the next video, we're going to go for the SIPO. Okay, so we finish our first video first. I want you to understand the SISO. Then after that, we're going to go for our SIPO. Okay, so thank you for your watching. Study smart and stay safe. Bye bye.